Okay, now let's take a look at solving rational inequalities. If you haven't already watched the video on solving polynomial inequalities, do that first, because the way we solve rational inequalities is with a sign analysis graph, just like the one for polynomials. There are two major differences if you compare this with the way we do the polynomial inequalities. The first difference is to get the critical values, you need to set the numerator and the denominator both equal to 0, okay? You may run into some problems where you have to factor the numerator or the denominator, but for the most part, these problems have a linear numerator and denominator, so it's really easy to find those critical values. The other difference is way at the end of the problem, okay? When you write your solution sets in interval notation, you will need to use a parenthesis on the critical value from the denominator. That value will never be included in the solution set because it makes the denominator equal to 0. We will use a parenthesis to indicate that, okay? So what that's saying is that you cannot include critical values from the denominator. To show that, we're just going to use a parenthesis, okay? When we do greater than or equal to or less than or equal to, that's when this will really need to be remembered, okay? If you're just doing less than or greater than, everything's a parenthesis anyway, and you don't have to worry about it. But it's when you have the or equal to that you really have to make sure you remember that, okay? All right, so now let's take a look at an example. And the one that we're going to work on is this one. X plus 3 over x minus 5 is less than or equal to 0, okay? Again, the first step is to make sure you have 0 on one side. If you don't, you need to move your constant over with a fraction and then rewrite that as one fraction, okay? There's an example of that in the textbook. Be sure you take a look at it. It's the example after they start talking about solving rational inequalities. I think it's the only example they did in the text, okay? So be sure you take a look at that one in addition to the one that we're looking at here, okay? Now, what we want to do first, besides the make sure 0 is on one side, we want to find the critical values. So for the rational, we set the numerator and the denominator equal to 0. We get -3 for the numerator and 5 for the denominator. I will usually mark the one that comes from the denominator. That's just so when I look back at it later, I remember which one it was, and so I'll know which one to use parentheses on, okay? You can also just look back at the beginning. You don't have to physically mark it, but I find that it makes life a little bit easier for me, okay? And what I'm going to do here is we're just going to go ahead and do the number line. I'm going to change it up a little bit from the way that I did the polynomial one in the previous video. I'm going to do the number line stuff first, and then we'll kind of match the two-dimensional graph to it, so you can see then once we have done it what it kind of looks like. Whoops, still on pan, sorry. All right, so I make my number line, and I mark those two values, a -3, and I mark a +5. Okay, now I need to pick a test point between and beyond, so pick one from each interval, just like we would on the polynomial. Maybe a -4 or -5 here, maybe 0, and then maybe a 6 on this side. Alright, and I'm going to extend this line on up just a little bit so I've got a little bit of space to work, just like I did before, okay? We are plugging into the rational equation, and it's x plus 3 over x minus 5. So when I plug in a -5, we get -5 plus 3 over -5 minus 5, and that gives me -2 over -10, okay? Which is going to be 1/5. That's a positive value. So this is going to be a positive interval. I'm just going to do the one big symbol this time. Plugging in 0 will give me 0 plus 3 over 0 minus 5. So -3/5 is what we get there. And then 6 goes in and gives me 6 plus 3 over 6 minus 5. That's going to be 9 over 1. Okay, so for that I get another positive interval. So it's positive, negative, positive, and you'll notice probably the majority of the problems you work will have that exact same pattern. Okay, positive, negative, positive. So much so that if you get something different than that, you might want to double check and just make sure you've got everything in the right place. Pay close attention and be sure that your test points are in the interval that they're supposed to be in. I know that sounds really stupid. Like, how would you not put them in the right place? But I've even myself in front of a class picked a test point that wasn't even in the interval I was choosing it for. So just be aware of that and be careful. It happens more with this one, the one that's to the far left, than any other one, okay? Just be aware of it. All right, so now we go back and we take a look. This is less than or equal to, okay? So the intervals that I want are going to be negative. That looks like it's just one interval down here, right? Oh, and I was going to pull that graph down too, so y'all bear with me for just a minute. Whoops. All right, I'm going to pause the video for a second and see if I can do that without making a mess. Okay, so it's kind of hard to see because I've got so much chicken scratch on top of it, but if you take a look at it, you've got right here where I had the -3, which is the numerator's critical value. I've got it right there. That's an x-intercept, okay? And it will be. Anything from the numerator on a rational is going to give you an x-intercept, okay? And you can see that on this side of the x-intercept, that critical value, the graph is in fact above the x, so that's positive, okay? Then between -3 and 5, the graph drops below the x-axis and then keeps continuing to drop down, okay? And it's hard to see because I've got so much garbage up here written on this other side because I've kind of just made it real cluttered, and I think I kind of pushed it up a little bit too. So anyway, the critical value from the denominator shows where we have this vertical asymptote, okay? And an asymptote shapes a graph. It's not a place where we cross any axis or anything like that, but it's like an invisible line that creates kind of a barrier in your graph. Notice that on both sides of this line, the graph just kind of pushes away from it, okay? Go up like that on this side, down like this on this side. So we're below the x-axis in the negative realm here, and then on the other side of the 5, we're up on the positive side because we're above the x-axis at that point, okay? So that's kind of what I wanted you to see from the graph. I'm going to pause and I'm going to get rid of that graph again so that it's a little bit clearer and cleaner while we write the answer. Okay, that's a little bit better. All right, so we're looking for the negative interval, the place where the fraction is less than or equal to 0. That's going to be the part in the middle. Keep in mind that we are doing less than or equal to. The 5 is what came from the denominator. That's the critical value from the denominator, so we'll use a parenthesis there and a bracket on the -3. We're going to grab the interval between those because those are the x values that produce a negative number when we plug them in. Less than's what we're looking for, and so we need the one that's negative. -3 to 5 is our interval notation, and that is our solution.